So we've been talking about electrons and the fact that they exist in these energy levels, but they don't have to exist in the same energy level for life. The normal place where you'd find an electron is called the ground state. It could be level 1, level 2, it could be level 3, 4, just depends on where that electron is normally found. But when that electron gains a specific quantity of energy, it can jump up to a higher energy level. We say that the electron is excited, or it's in an excited state, which is not stable. High energy is always associated with instability. So we want to bring that electron back down to its ground state, but we have to release all that extra energy before the electron can move to a lower energy level. Now, that energy is released in the form of different types of light energy, and if it falls in the visible light spectrum, we can see it and experience it in the lab. So we were looking at emission tubes the other day, where we used electricity as our energy source in order to excite the electrons. And we saw the electrons fall back down, or evidence that the electrons are falling back down to the ground state by seeing the different colors of light released from those like skinny little emission tubes, where they're filled with different gases. And it's kind of cool, right? So I want to show you a couple other options today. We're going to use a different energy source. We're going to use heat as a source of energy to excite the electrons. And instead of getting it from like a tube of gas, we're going to use some solid compounds. So first, I need my energy source, which will be a Bunsen burner. And so we'll put on the goggles, right? Safety first, safety always. Okay, so perfect. I'll bring this down. And I'm going to light the burner. There it is. That's not too bad. Get the camera in the right spot. I like it. Okay, so then I've got some Q-tips. Q-tip, there it is. And I'm going to just kind of wet the end of the Q-tip. And then I'll put it in a solid chemical. So this right here is, whoopsies, lithium chloride. And it's just a white solid. And so I'm going to take this kind of wet Q-tip and dip it in there and try to get some of the solid to kind of stick to the end of the Q-tip. And then we'll burn it. And can you see kind of like this pinkish, kind of crimson color? Isn't that kind of cool? Kind of like a pinkish red color. That's called the flame test. And it's similar to what we did with the emission tubes. And you can't really use like the prism very well with this demonstration to try to separate into all the specific bands of light that are being emitted, just because there's other forms of energy emitted too. There's other light waves from the heat of the burner and the burning of the methane gas. But overall, I'm seeing kind of like this reddish pink flame. And it would be kind of a low energy color in the electromagnetic spectrum. The reds and the oranges are the low energy colors. And so I could assume that the electrons in this lithium compound are making kind of smaller jumps. They're gaining small amounts of energy, and then they're falling back down, releasing small amounts of energy. So that one's lithium. In the same way, let's test a couple other ones. Now, some of these I think you can see a little better than others, but this one's a calcium chloride. Calcium chloride kind of burns with this really bright, almost a yellowy flame. So maybe kind of a moderate energy level, where the electrons are overall making kind of moderate jumps and releasing moderate amounts of energy. And again, if I had a prism that could kind of filter out other forms of energy being emitted, maybe there's different wavelengths in this mixture of light, but what I see is kind of like a yellowy color. Cool. This is usually one of the most fun labs, and I feel so terrible that you can't do it yourself. Playing with colored fires, gotta be a good thing, right? Maybe, kind of. Okay, so that was lithium chloride, then calcium chloride. How about, let's try potassium chloride. So same way, I'm like taking the Q-tip. This is, where is it? Potassium chloride. I have just a wet Q-tip, and I'm kind of rubbing it in the solid, trying to get some of it to stick to the Q-tip. sometimes you can see this one, and like I'm seeing it better in person than what I see on the video, but it's almost kind of a lavender. You'll get like a light purple from the potassium, which is kind of cool. I don't know if you can see a little bit of a light purple in there. So, I mean, purple or violet would maybe be a little bit of a higher energy color. So the electrons are making bigger jumps and then releasing larger amounts of energy as they fall back down to the ground state. Here's strontium. So it's strontium chloride. And so I got my wet Q-tip. See that one? Like this is another one that's kind of like a orangish red almost. And you can see it's a different color. I don't know if you can see the red in there. But it's like a nice pretty orange red. It's really cool. But again, maybe like a lower energy color on average. There's a little bit of red in there. And so the electrons are making lower energy jumps. I also have, this one is kind of cool. It's green. Let's see if I get in there. Can you see it? A little bit. This one is a copper chloride. It's a really pretty green color. And it burns with like a bright bluish, like a kind of a bluish green. That one's pretty cool, which, the blue in there is definitely more of a higher energy color. So this would be another element where the electrons are gaining higher amounts of energy and then they're releasing higher amounts of energy as they fall back down to their ground state. Pretty cool. I have one other one. If we don't see a good color with this one's sodium chloride. Here it is, sodium chloride. I've got another option, like if we don't see this one great, with the sodium chloride. It is kind of like a bright orange. It's kind of cool. You can see that pretty nicely. So orange, maybe a little bit lower energy color, lower energy transitions up and down the energy levels. Gosh, that's so cool. It's like mesmerizing and having so much fun. I hope you're having just as much fun watching me. Okay, so all of those were chlorides. They all had some kind of a metal like sodium, and they were all bonded to chloride. So what if I ask you this? Do you think the flame test was showing the color of the metal, like the sodium, or do you think it was showing the color of the chlorine? So we tested potassium chloride, strontium chloride, lithium chloride, copper chloride. They were all chlorides. But if the flame test represented the color of the chlorine, then wouldn't they have all been the same color? And obviously they were different. So this flame test method is great for getting the energy level and the transitions of metals. And so it really gives you the color of the metal, not the chlorine. And you can see that in this. Like, okay, so here was the copper chloride, which was kind of a green color. Well, this is a mystery unknown A. It's blue. I don't know if you can kind of see it. It's a blue solid. I didn't test any blue solids yet. I don't know if you can kind of see this one. It's also kind of like a greenish blue flame. It's the same flame that you get with copper chloride. So when you see two elements that are giving off this, or two samples that are giving off kind of the same colors here, we can assume that maybe they have the same metal. This blue one is a copper sulfate, whereas the other compound was a copper chloride, but their flame test was the same. Same kind of thing. Usually I get a good test with this one. We tested strontium chloride. Oh. Every now and then, can you kind of see like this red, kind of a crimson red in there? Well, this is strontium nitrate. It's the same compound, it's the same metal. They're both having strontium in them, and so you get kind of the same observation. Cool, cool, cool. Okay, so I'm going to turn the burner off for a second. And I'm going to tell you this. Let's see if I got this in the right spot. So often these colors are pretty bright. Like it's easy to see the reds and sometimes like the purple violet of potassium, and sometimes it's easy to see the cool green color of the copper. Some of them are a little hard when you get this flame test. Like the sodium is sometimes kind of tricky because its flame test is kind of orange, but you're like, well, orange is like the color of fire. I don't know. Like, so how do I know that it's not the fire and that it is the sodium? So I've got another option for you. Okay, so let me get something. I have a jar of pickles, some Milwaukee's Finest pickles. And if I read, here it is. If I read on like the ingredient label, number 1 is cucumbers. Number 2, water. Number 3, salt, sodium chloride. So these pickles have been swimming in like a salty brine for I don't know how long. I guess it doesn't really say when I bought it. I don't know, like a month ago or whatever. So they should have all kinds of sodium chloride absorbed into the pickle. And so we'll see if we can add energy to the pickle in order to see the flame test of the sodium. So I guess I could like burn the pickle, we could, but instead let's go back to that electrocution method. Let's electrocute the pickle, and we'll use electricity as the energy source, and we'll see if we can find the flame color of sodium hiding in there. Okay, so I'm gonna have to try to get my camera down here. So there's my pickles, and then here's what we're going to do. I'll see this better in a second. So I've got this block, electric pickle, and I have 2, it's kind of dark. I have to have the lights off for this. These are just forks, like old forks. So I'm going to put these old forks in the block, in the wood block, and then we'll stab a pickle in there. So, ooh, this is a nice one. Okay, well, let's see if we can kind of see that. And it's dark, but there is a pickle on these forks. Let's see if I put it in the light. Electric pickle. There it is. It's like a pickle on 2 forks. We're going to electrocute the pickle. Oh, yeah. I think we got it. Okay, so I've only electrocuted myself once doing this. Live and learn, right? Okay, so then I have like an old cord. This cord used to be like on an old hot plate, and we stripped the cord off, and then I don't know if you can kind of see it. I just put some alligator clips on the end of it, and so I'm going to hook the alligator clips up to the forks. And then we'll plug it in. And then we'll see if you notice any changes. Oh my gosh, you gotta be kidding. Check it out, it's like that yellowy orange color. It's the exact same color that we got from the flame test, because the flame test shows the color of the sodium. So whether it was from a pickle that had sodium chloride, whether it was from like the solid sodium chloride that I tried, you should still see the same representative colors when you do this flame test. The smell is absolutely weird. I was almost going to say wonderful, but it's really not wonderful, it's weird. Yikes. We'll put it out of its misery for a second. I don't know if you've ever smelled burnt pickle before, but it almost kind of smells like burnt hair. It's very strange. So we sacrificed 1 pickle for science. But it's kind of similar to like the fact that in the textbook they mentioned this bright line emission spectrum as being kind of like a fingerprint, that it's specific to a particular element. And if I had the means of like separating that orange light into all of its specific colored bands, then we should see the exact same pattern, whether I electrocuted the sodium in the pickle or whether I heated the sodium in a solid sample of salt. So it's, I think, kind of cool. And really fun to play with here all by myself in the lab. So I hope this kind of helped just to kind of understand this idea of electrons moving up and down the energy level, how we have to add energy in order to excite the electrons. We can use different sources of energy, electricity, heat, and that if we look at the colors, we can kind of infer what type of transitions the electrons are making. When I see the low energy reds and oranges, I can assume the electrons are gaining small amounts of energy and then releasing small amounts of energy. If I see more of the blues and violets, then I can assume that the electrons are gaining larger amounts of energy and releasing larger amounts of energy.